Hello students, today we will learn chapter number 3, playing with numbers of standard 6 maths NCERT. We will start with the first point, that is factor. Now what is a factor? A factor of a number is an exact divisor of that number. Now I will explain you with the help of the example. Suppose a number is given 4. Now we want to find out the factors of 4. We will see that which numbers exactly divides 4. We will take the numbers which are smaller than 4. We will start dividing by 1. 1 4s are 4. 4 minus 4 is 0. Remainder is 0. Then we will move with 2. 2 2s are 4. 4 minus 4 is 0. Again remainder is 0. Then we will divide with 3. 3 1s are 3. 4 minus 3 is 1. Again the remainder is over here is 1. Then 4 divided by 4. 4 1s are 4. Remainder is 0. Now here you can see that in all the numbers remainder is 0 except 3. We can also write as 1 4s are 4. 2 2s are 4 and 4 1s are 4. Whereas by 3 if you divide, the remainder is 1. If the remainder comes 0, then all the factors, all the divisors will be the factors. So we can say factors of 4 will be 1, 2 and 4, as these three numbers are the exact divisor of 4. Now we will move to multiple. A number is a multiple of each of its factors. Now suppose I am taking 6. Factors of 6 are 1, 2, 3 and 6. And 6 also comes in the table of 1 6s are 6, 2 3s are 6, 6 1s are 6. So 6 is a factor. 6 can be said as a multiple of 1, 2, 3 and 6. Other example if we want to take, suppose we are taking 8. Multiples of 8 will be 8 1s are 8, 8 2s are 16, 8 3s are 24, 8 4s are 32, 8 5s are 40. So the multiples of 8 will be 8, 16, 24, 32, 40 and so on, as multiples are infinite. Now we will see some points for factors and multiples, or we can say some rules for factors and multiples. The first point is 1 is a factor of every number. Now 1 is a factor of every number. Suppose I am taking 6. Factors of 6 are 1, 2, 3 and 6. Here 1 will be the factor of a given number, that is 6. Second point, every number is a factor of itself. Same example, 1, 2, 3, 6. Factors of 6 are 1, 2, 3, 6. Every number is a factor of itself. Here 6 is a factor of the given number, that is itself 6. Third point, every factor of a number is an exact divisor of the given number. Here we can say that 6, 1, 2, 3 and 6. Here all these numbers 1, 2, 3 and 6, they are easily divisible. They are divisible by the number 6. It will leave the remainder 0. Fourth point, every factor is less than or equal to the given number. We will take the same example, 1, 2, 3 and 6. Factors of 6 are 1, 2, 3 and 6. Every factor is less than. Now 1, 2 and 3, these are the factors and they are smaller than 6 or equal to, and this is equal to the given number. So every factor is either less or it is equal to the given number. Fifth point, number of factors of a given number are finite. Finite means limited. Same example we will take 6, 1, 2, 3 and 6. Limited 1, 2, 3 and 6. These numbers are limited. There are no any other numbers beyond 6. So only factors are limited, or we can say they are finite. Now we will see the points for multiples. First point, every multiple of a number is greater than or equal to that number. We will take an example 8. Multiples of 8, that means we will write down the table of 8. 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40, and so on. Now every multiple of a number is greater than. Now you can see this 16, 24, 32 and 42. All these numbers or all these multiples are greater than 8, or it is equal to the number. So 8 is equal or it is greater than a given number. Second point, the number of multiples of a given number is infinite. Infinite means limited. Same example 8, we will write on the table of 8. 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40, and it will go on continuing. That means these numbers are infinite, unlimited. Third point, every number is a multiple of itself. Now 8, we will start with 8 ones are 8, 8 twos are 16. So every number will be a multiple of the itself, that is the given number. Let us move to the next topic, perfect number. Now what is the meaning of perfect number? A number for which sum of all its factors is equal to twice the number is called a perfect number. Let us explain or understand with the example. I am taking 6. Factors of 6 are 1, 2, 3 and 6. Now we have to add or we have to sum up all its factor. If you sum up all its factor, it will be 1 plus 2 plus 3 plus 6. If you add these numbers, 1 plus 2, 3, 3 plus 3, 6, 6 plus 6, 12, and 12 is the double of the given number, that is twice the number. So we can say that 6 is a perfect number. Let us see another example, 28. Factors of 28 are 1, 2, 4, 7, 14, 28. These are the factors of 28. Now we will add these factors. So 1 plus 2 plus 4 plus 7 plus 14 plus 28. If you add this number, you will get 56, and 56 is double of 28. So we can say 28 is a perfect number. Now let us see another example, 10. Factors of 10 are 1, 2, 5 and 10. If you add the numbers, 1 plus 2 plus 5 plus 10. 1 plus 2, 3. 3 plus 5, 8. 8 plus 10, 18. And 18 is not the double of 10. So 10 cannot be called as a perfect number. Now let us see prime numbers. Numbers other than 1 whose only factors are 1 and the number itself are called prime numbers. That means if the numbers have only 2 factors, 1 and the number itself, they are called prime numbers. Now let us see what are composite numbers. Numbers having more than 2 factors are called composite numbers. So numbers which have more than 2 factors, they are called composite numbers. Now here it is written 1 is neither prime nor a composite number. Now we will bifurcate how we can see prime numbers and composite numbers. Here numbers I have written from 1 to 8. First we will write down the factors of the given numbers. So factor of 1 is 1. So number of factors is only 1. Now 2. Factors of 2 are 1 and 2. Total number of factors 2. 3. Factors of 3 are 1 and 3. So total number of factors are again 2 over here. 4. Factors of 4 are 1, 2 and 4. Total number of factors 3. Then 5. Number of factors 1 and 5. So total number is 2. 6. Factors of 6 are 1, 2, 3 and 6. Total number of factors are 4. 7. Factors of 7 are 1 and 7. Total number of factors are 2. Then 8. Factors of 8 are 1, 2, 4 and 8. Total number of factors are 4. Now here we can see which are the prime numbers and composite numbers. Now this number of factors are 2, here also 2, here also 2 and here also 2. So we can say 2, 3, 5, 7. They have only 2 factors. So these numbers are called prime numbers, whereas 4, 6 and 8 they have more than 2 factors. So they are called composite numbers. So in this way we can see prime numbers and composite numbers. Now let us see what is an even number and what is an odd number. First we will see even number. Numbers with 0, 2, 4, 6, 8 at the ones place is an even number. So the numbers like 0, 2, 4, 6 or 8 at its unit place, then that number will be called as an even number. Suppose I am writing 20. Now 0 is at its units place, or we can say at ones place. So 20 is an even number. 324. 4 is at its units place. So 324 is an even number. Here 6. 4696. 6 is at units place. So this number is also an even number. 2988. Here 8 is also at its units place. So this number is even number. Now we will see odd numbers. Numbers with 1, 3, 5, 7, 9 at its ones place, that is called an odd number. For example 11. Here 1 is at unit place. So 11 can be called as an odd number. 23. 3 is also at its unit place. So 23 can be called as a odd number. Here 5. 5 is also at its unit place. So 655 is also an odd number. 797. 7 is also at its unit place. So 7 can be called as an odd number. 99. 9 is again at its unit place. So 99 can be called as a odd numbers. Now we can see some 2 points. First point, 2 is the smallest prime number which is even. Now prime number we all know that it has only 2 factors, 1 and the number itself. So among this prime number, 2 is the smallest prime number and that number is even. Second point, every prime number except 2 is odd. So all the prime numbers except 2 is odd, whereas 2 is the even prime number. Now we will see tests for divisibility of numbers. The first test is divisibility by 2. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its one place. If the digits like 0, 2, 4, 6 or 8 are at one's place, then that number will be divisible by 2. 20. 0 is at one's place, so 20 will be divisible by 2. 62. Again here 2 is at its one's place, so 62 will also be divisible by 2. 344. 4 is at its one's place, so 344 will be divisible by 2. 266. 6 is at one's place, so 266 will be divisible by 2. 898. Last digit, that is one's place, is 8. So 898 will be divisible by 2. Now we will see divisibility test for 3. If the sum of the digit is a multiple of 3, then the numbers is divisible by 3. Sum of the digits. Now example is 225. 2 plus 5 is 7. 7 does not come in the table of 3. So it is not divisible by 3. Now 37. 3 plus 7. Sum of the digit is 9. 9 comes in the table of 3. We will see the divisibility test for 4. A number with 3 or more digits is divisible by 4 if the number formed by the last 2 digits, that is at ones and tens place, is divisible by 4. For the test for 4, we have to see the last 2 digits of the given number. If these digits are divisible by 4, that means it comes in the table of 4, then the complete number will be divisible by 4. First, 212. Last 2 digits at ones and tens place is 1 and 2. So 12 is divisible by 4. Second example, 1936. 36 also comes in the table of 4. So 1936 is also divisible by 4. 9532. At ones and tens place, the number is 3 and 2. And 32 comes in the table of 4. So the complete number 9532 is divisible by 4. Now the divisibility by 8. A number with 4 or more digits is divisible by 8 if the number formed by the last 3 digits is divisible by 8. That means if the last 3 digits is divisible by 8, then the complete number will be divisible by 8. Here last 3 digits are 0. These 3 zeros will be divisible by 8. 104. 104 if you divide by 8. 8 ones are 8. 10 minus 8 is 2. Carry down 4. 8 threes are 24. Remainder is 0. So this complete number is divisible by 8. Same way 1460. We will see the last 3 digits. 416. 8 5s are 40. 16. 8 2s are 16. So remainder is 0 over here. So this complete number is also divisible by 8. Now the test for 9. If the sum of the digits is divisible by 9, then the number itself will be divisible by 9. Sum of the digits. Sum of the digits means you have to add the numbers. 1 plus 8, you will get 9. And 9 is divisible by 9. 27. 2 plus 7, again it will be 9. 9 also comes in the table of 9. So it is divisible by 9. 36. 3 plus 6 is also 9. So 36 is also divisible by 9. 846. 8 plus 4, 12. 12 plus 6, 18. 18 comes in the table of 9. So 846 is also divisible by 9. Now divisibility by 10. If a number has 0 in the ones place, then that number will be divisible by 10. So at unit place, the number should be 0. It can be any number, 20, 3000, 850. Here the numbers are 0 at its ones place. So these numbers will be divisible by 10. Now the divisibility test for 11. First of all, you have to find the difference between the sum of the digits at odd place from your right hand side and sum of the digits at even place from the right hand side of the numbers. After that, if the difference is either 0 or if it is divisible by 11, then the complete number will be divisible by 11. So first we will see the numbers and we will write down the numbers from the right hand side. 308. First we will write the numbers 1, 2, 3 from the right hand side. Now we will add up the odd digits. At odd digits the number is 8 and 3. So 8 plus 3 is 11. Even place, the digit over here is 0. So the difference will be 11 minus 0. And 11 comes in the table of 11, or 11 is divisible by 11. So 308 is divisible by 11. Now let us see the other number, 1331. We will put the numbers 1, 2, 3 and 4. First we will add up the odd places. So at odd place the number is 1 plus 3. So 1 plus 3 is 4. Now we will take the even place. At even place the digits are 3 and 1. So 3 plus 1 is 4. If you take the difference, 4 minus 4, 0. So the rule says if the number is either 0, then this number will also be divisible by 11. So 1331 is divisible by 11. Let us move to the other number. 61,809. First again we will write down the numbers. 1, 2, 3, 4 and 5. First we will take the odd numbers. At odd places the numbers are 9 plus 8 plus 6. 9 plus 8, 17. 17 plus 6 is 23. Now we will take the even place. Even place is 0 plus 1. 0 plus 1 is 1. Now we will see the difference. 23 minus 1 is 22 and 22 is divisible by 11. We will move to prime factorization. When a number is expressed as a product of its factor, we say that the number has been factorized. A number is given, we have to express these numbers as a product of its factors. First method is factor tree. Now 36 can be written as 2 18s are 36 and 4 9s are 36. Now to 18 can be expressed as 2 9s are 18 and 9 can be expressed as 3 into 3. 4 9s are 36. 4 can be expressed as 2 into 2 and 9 as 3 into 3. So we can say 36 can be expressed as this product in the form of 2, 2, 3 and 3. Here also the same number. So 2 multiplied by 2 multiplied by 3 multiplied by 3. Now the second method is division method. Now a number is given 980. We have to divide the numbers continuously. So we will start with 2. 2 divided by 980, that will be 490. Now 490 is again divisible by 2 as the digit is 0 at the last place. If you divide 490 by 2, 2 2 is 4. 9 2 4 is 8. 9 minus 8 is 1. 0. 2 5 is 10. So 245. Now the digit is 5. So it will be divisible by 5. If you divide 245 by 5. 5 4 is 24. Carry down 5. 5 9 is 45. The remainder is 0. So it will be now 49 comes in the table of 7. 7 7s are 49 and 7 1s are 7. So 980 can be expressed as 2 into 2 into 5 into 7 into 7. So this was the division method. Now let us see what is the common factor and what is the meaning of common multiples. One example is given 4 and 18. First of all, we will write down the factors of 4. Factors of 4 are 1, 2 and 4. Factors of 18, 1, 2, 3, 6, 9 and 18. Now we have to find out the common factors. That means both the factors should occur in the same, both the numbers. Now here 1 is common as well as 2 is common. Rest of the numbers are not common. So common factors of 4 and 18 is 1 and 2. Now let us see two numbers having only 1 as a common factor are called co-prime numbers. That means if there is no common factor other than 1, then that number is called co-prime factor. Let us see one example, 4 and 15. Factors of 4 are 1, 2 and 4. Factors of 15 are 1, 3, 5 and 15. Now there is only common factor, that is 1. So 4 and 15 they are called co-prime numbers. Now let us see common multiples. In common multiples you have to write down the table of 4 and 6. We will start with 4. 4 1 is 4. 4 2 is 8. 4 3 is 12. 4 4 is 16. 4 5 is 20. 4 6 is 24. 4 7 is 28. 4 8 is 32. 4 9 is 36. It will be continued. Now let us take 6. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 13, 6 6s are 36, 6 7s are 42. Now from this 12 is seen in both the numbers, 24 is seen in both the numbers, and 36 is also seen. So 12, 24 and 36 are the common multiples of 4 and 6. Now highest common factor, or in short it is said as HCF or GCD, that means greatest common divisor. The HCF of two or more given numbers is the highest. Let us see the example. Find the HCF of 20, 28 and 36. Now we will find out the HCF of 20, 28 and 36 by division method. 2 10s are 20, 2 5s are 10, 5 1s are 5. Now we will take 28. 2 14s are 28, 2 7s are 14, 7 1s are 7. 36. 2 18s are 36, 2 9s are 18, 3 3s are 9, 3 1s are 3. Now we will write on the factors. Factors of 22 into 2 into 5, 28, 2 into 2 into 7, and 36, 2 into 2 into 3 into 3. Now we have to see the common numbers. Common numbers is 2, which occurs twice. Here also 2 is given. So the common number is 2. So common HCF will be 2 into 2. So highest common factor will be 4. Lowest common multiple, or in short it is referred as LCM. LCM, or the lowest common multiple of two or more given numbers, is the lowest or smallest, or we can say least of their common multiples. Let us see the example. Find LCM of 12 and 18. Now here for LCM we will take both the numbers together. 2 6s are 12, 2 9s are 18, 2 3s are 6. 9 will remain as it is because it is not divisible by 2. Now we will take 3. 3 1s are 3, 3 3s are 9, and again 3 1 as it is, and 3 1s are 3. So LCM of 12 and 18. 2 multiply by 2 multiply by 3 multiply by 3. You have to multiply. 2 2s are 4, 4 3s are 12, 12 3s are 36. So LCM of 12 and 18 is 36.